Hello everyone, welcome back to OrganiChemVerse. Today let's solve one more question based on organometallic compounds. So what is the question here is that there are two reactions given here, reaction 1 and 2. Then you have to find out what are the products A, B, C, D and then check for the statements given here and choose the right options. Now, what is the first reaction? The first reaction is between a cyclopentadiene molecule with N-butyl lithium. N-BULI refers to N-butyl. That means a long chain of butane as a carbanion. That's why N-butyl lithium. This is the organometallic compound. Why is it called organometallic compound? Because the carbon is directly attached to the metal. In this case, it's a lithium ion. So these organometallic compounds either act as a base or as a nucleophile. If it attacks the carbon, then it's a nucleophile. If it abstracts the proton, then we call it as a base. So in this case, how it is going to act? So that is answered by the molecule given here. Look at this. This is cyclopentane with two double bonds. So there are two hydrogens here. And these hydrogens are somewhat acidic in nature. Why so? Once this carbanion abstracts the proton, so the hydrogen goes as a proton. So what happens to this carbanion? It's going to form a butane like this. And then what happens to this? It's going to form a carbanion. You are abstracting the proton. So the bond pair electrons are given to the cyclic molecule like this. And this is balanced by the counter ion lithium. So you are preparing one more organometallic compound. So why this is happening? Because the formed product here is aromatic in nature. How do you know it's aromatic in nature? Very simple. Check for these four rules. It is cyclic and it is having continuous conjugation, that is double single, and there is a lone pair of electron. That means all the carbons here are sp2 hybridized. So the last one is Huckel's 4n plus 2 rule. So all these rules are satisfied, right? So that's why this is aromatic. That is the driving force for this reaction to happen. Say let's assume this is A and this is B, because in the next second reaction you see here A is used. The butane molecule is not reactive, right? So you can ignore this and assume this as A. Now this A, right? So how do you call this? As cyclopentadienyl carbanion, right? So this is going to react with, there is a ether given. So like this, ether given. Of course, there will be a lithium as a counter ion. Now, where should the negative charge of the carbanion must attack? So this is the reactive center because this is partially positive due to the halogen. So the negative attacks the positive, and chlorine will leave as chloride and it will form a lithium chloride as a byproduct. So what is our main product? The organic product. So there is a carbon-carbon bond formation here like this, and then we have this is a CH2, right? So this is a CH2 and then there is a oxygen and then methyl. So this is the product formed here. Now, what happens in the next case? So this is product C when it is treated with hydrogen in presence of platinum. See, the formed product is not aromatic here. This is, the carbon here is sp3 hybridized. Therefore, what happens to this? This is a non-aromatic. So non-aromatic compounds like a simple cyclopentadiene molecule can undergo addition reaction easily. Aromatic compounds will not undergo addition that easily. But since it is a non-aromatic compound, what happens here is it will simply undergo addition reaction. Therefore, what you are going to get here is like this. So both the bonds will get reduced. So although there is no 2 moles given and all, but it's understood that both the double bonds will be reduced because this is a catalytic hydrogenation. There won't be any control on the reduction. That is the reason. So this will be our product D. So once you're done with writing the reactions, check for the statements. A is a homocyclic compound. So what is A? This is A. Homocyclic means what? A cyclic molecule with the same type of atom. So since it's an organic compound, all the atoms must be carbon, which is correct. It doesn't matter whether it's aromatic, anti-aromatic, non-aromatic. It's simply homocyclic. Is it homocyclic? Yes. Therefore, this is a right statement. Now, D on treating with one equivalence of concentrated hydrogen iodide produces a primary alkyl halide predominantly. Let's check for that. So this is a reaction of ether, right? So what happens in the first step? This oxygen is going to get protonated, right? So I'm going to write this over here. So this cyclopentane is as it is. Now the oxygen is going to get protonated due to the presence of the acid. Now the iodide should attack. So the question is, will it undergo SN1 or SN2? So in this case, it's going to be SN2. Why so? Because you see here also we have a primary carbon. Here also there is CH3. There won't be any possible carbocation formation. So it has to be SN2. So in SN2, the iodide always attacks from the less sterically hindered side. You see there is a cyclopentyl group. So there is a steric hindrance. That means there is no space for the iodide ion to attack. So simply you can show it like this. The bond will break here. So what will be this product? So it's going to form methyl iodide. What about this? This is going to break here. So it's going to form a primary alcohol. Now the question is about the alkyl halide. So let's read the statement again. D on treating with one equivalence of HI produces primary alkyl halide. Predominantly, yes, it is forming, that is nothing but methyl iodide. So this is also a true statement. Now, C doesn't decolorize bromine water. So what is C? This is C. So it does decolorizes bromine water. So this is a reaction of an alkene with bromine. Since this molecule is non-aromatic, as I told you. So the non-aromatic compounds easily undergo addition reaction with bromine and decolorizes the bromine water. Hence, this is a wrong statement. C does decolorize bromine water. That is a true statement. So given statement here is wrong. Now A is a organometallic compound. Yes, this is correct because what happens is the carbon of the alkyl or cycloalkyl, whatever chain we have, it is directly attached to the metal here, that is lithium ion. Hence A is also an organometallic compound. So this is also a true statement. So among the given statements, A, B and D are the right statements. I think I made this question clear to you with the proper explanation, and if you still have any questions, you can comment them in the comment section, and don't forget to subscribe the channel. Thank you.